This video is going to help you get ready to learn trigonometry. So we have explored algebra and we have explored geometry, and you are going to be getting into trigonometry now, but there's a little bit of groundwork we want to do before we get there. So first, what is trigonometry? So trigon is Greek for triangle. You guys could have guessed that based on the picture on the screen. And then anytime you see metry, which you definitely have seen before, that is the process of measuring. So if we put those two pieces together, trigonometry studies relationships between side lengths and angles of triangles. So we are exploring triangles, and more specifically, we're going to be measuring their side lengths and their angle measures and relating the two. So angle measures and their side lengths. Let's discuss how they relate to one another. So using the triangle pictured, can you sort the angle measures from least to greatest measure? So hopefully we all remember that a triangle adds up to 180 degrees and that this symbol means 90. So if angle B is 90 degrees and we know that a triangle adds up to 180, then we know that our two remaining angle measures must be less than 90 degrees. And if they're less than 90 degrees, then I know that my greatest angle measure is going to be angle B. So that's going to go on the end. So angle B will be the largest or the greatest measure. We don't have any other numbers, but just by eyeballing, it looks like angle A is the smallest, so angle C would be my middle length. Angle A looks like it's not opening as much as angle C is, so angle A is the smallest, and then angle C and angle B. Using the same triangle, can you sort the side lengths from least to greatest length? Again, if you eyeball it, it looks like length CB is the smallest, and then AB would be the middle length, and AC would be the longest length. The question that we're asking is, what do you notice? Well, angle A is right here, so that'd be this corner, and it is across from side length CB. What do you notice about those two? Angle A was my smallest measure, and angle or side length CB is my smallest length. And let's see if that holds true for the others. Angle C would be up here, and then it is across from AB. Angle C is my middle measure. Side length AB is my middle length. And then lastly, let's go with angle B. So right here, and it is across from AC. And notice that B is my largest angle measure, AC is my longest side. So what do we notice? We'll put it in red. So the order of the angle measures is the same as the order of the side lengths. So largest angle is across from largest side. And then we could keep going and say the smallest angle is across from the smallest side, and the middle-sized angle is across from the middle-sized side. So let's go back to talking about the angles inside the triangle. If a right angle is present, like it is in this picture, is it always the largest angle? Well, again, let's discuss all triangles should add up to 180 degrees. And if this is 90 degrees, there is no way that one of these angles could also be 90, because then this one up here would have to be 0, and there's no way that's possible. What about larger than 90? What if this was 91? If this was 91, clearly we're already over 180 degrees, so we know that can't be the case. So maybe 89, this could be 89 degrees, which would make the third angle 1 degrees. But no matter how you work it, 90 degrees is going to be the largest angle measure. And if that is true, then that means this side length across from it is going to be the largest side no matter what. So the side length across from the 90-degree angle is always going to be your largest side. And since that is the case, when you have right angles, you have right triangles, and the side length opposite the 90 degrees is always your largest side, we are going to name that, and some of you already know the name, but this will always be what is called your hypotenuse. The side length opposite your 90-degree angle will always be called your hypotenuse, and it is always your longest side. So then the next question, I erase here and we start over. Will there always be 3 different side lengths? So let's give these some fake side lengths here. So maybe this is 10, maybe this is 8, and this would have to be longer than 8 and 10. And then actually, I should probably use accurate side lengths. So let's say this is 4, this is 3, this would have to be longer than that, and this would be 5. So will you always have side lengths that are different from one another? Well, that would be true if we have angle measures that are all 3 different. But is there a chance that we could have side lengths that are the same? Only if your angle measures here and here are the same. And the only way to split up the remaining 90 degrees is by 45 and 45. So in that case, we could have congruent side lengths, but that would be the only time. Your hypotenuse would still be your longest, and then the other 2 would be shorter but the same length. About naming the sides of a triangle, we know that this is going to be our hypotenuse. And how do I know that? It is opposite my 90-degree angle. So over here, same thing. All right, so when we're talking about right triangles, the other 2 side lengths we can call legs. So this would be a leg and this would be a leg. However, when we want to be more specific about which leg we're referring to, we use an angle measure as a reference point. So I'm going to erase the words legs. And I'm going to look at this symbol right here. And this means this is theta in Greek. And it's kind of like when we use x for length. So we use x for length. And we usually use theta for degrees. Okay, so you'll see the theta symbol quite a bit when we're talking about trigonometry. So if I'm looking at my triangle and I see theta is right there, there are 2 words that we use to label or to reference the sides of the triangle. One of them is the opposite leg, and the other one is called the adjacent leg. And how would I know which is which? Well, it all depends on which angle measure you're working with. So if I use theta here and I go directly across, that is going to be called my opposite leg. And adjacent means next to, so this would be my adjacent leg. Now, some of you might be thinking, well, the hypotenuse is next to theta as well, but the hypotenuse is always called the hypotenuse, so that one never counts. So there's always a hypotenuse, and it's the angle, or it's the side length across from the 90-degree angle. And then there's an opposite leg and an adjacent leg. Adjacent is next to the angle measure, and the opposite leg is literally opposite. So if we look at this other example, it is the same triangle, but this time my opposite leg has changed because my angle measure is in a new position, and my adjacent leg has changed because of my angle measure. So we've got the opposite leg and the adjacent leg in different spots this time because our angle measure has changed. Recap a little bit about what we've learned so far. So we've got a right triangle, and this one we've got 38 degrees, 52 degrees, and then the 90-degree angle. So why don't you pause this video and list in order the lengths from least to greatest and then explain how you know. All right, so least to greatest, and we're talking about the lengths. So it looks like my smallest angle is 38 degrees and it is opposite XY. So XY must be my smallest side length. And then 52 degrees would be my middle length and it is opposite YZ. So that would be my middle side length. And then my 90-degree angle is always my largest and it is opposite XZ. How do we know that? Well, I know it because the larger the angle measure across from it, the larger the side length. So the angle measure across from it decides the length. Which side length is opposite 52 degrees? So if I erase all these markings and start over again, which side length is opposite 52 degrees? Well, literally opposite would be YZ. And which side length is adjacent to 52 degrees? Well, it is either XZ, which would be right here, or it's XY. Well, we all learned that the side length opposite your 90-degree angle is always called your hypotenuse. So this one cannot be adjacent. That leaves XY as my adjacent side. All right, and that is it for our intro to trigonometry.